Hey everyone! Welcome back to BugNoJutsu, where coding, anime, and problem solving come together. In today's video we'll solve a fantastic Leetcode problem, finding pairs with a certain sum. This problem is a classic example where brute force simply won't work for larger inputs, and we'll dive deep into how to crack it with an optimized approach. So make sure you stick around till the end because I'll also share my key takeaways and tips that you can apply to many similar problems. Let's jump in. Alright, let's first understand what this problem is asking. We're given two integer arrays called nums1 and nums2. We need to build a data structure that supports two operations. First, we can add a value to an element at a specific index in nums2. Second, we can count the number of pairs where a number from nums1 and a number from nums2 sum up to a given target. The task is to implement this system efficiently. That's it. It's essentially about efficiently tracking pair sums after repeated updates. Let's now walk through an example, which is the best way to fully understand this. Suppose nums1 is 1 1 2 2 2 3 and nums2 is 1 4 5 2 5 4. We first call count 7. We need to find all pairs where numbers from nums1 and nums2 add up to 7. Let's check manually. Pairs like 2 5 and 3 4 will sum to 7. We find a total of 8 valid pairs here. Then we call add 3 2. This means we're adding 2 to the number at index 3 in nums2. Nums2 now becomes 1 4 5 4 5 4. Calling count 8 now gives us pairs that sum to 8. We find 2 such pairs. You can see how after every update, the results change. The beauty of this problem lies in designing an approach that gives correct results even after these updates. Now let's talk about the solution. But I won't bore you by reading the code line by line. Here's the core idea behind the efficient approach. First, we use a frequency map or HashMap to store how many times each number appears in nums2. This makes it fast to check how many numbers in nums2 can form a pair with numbers from nums1. When we need to add a value to a specific index in nums2, we simply decrease the count of the old value in the frequency map, update the number in the array, then increase the count of the new value. This ensures that the frequency map always stays accurate. Now for counting pairs, we simply loop through each number in nums1. For each number, we calculate the target complement needed from nums2. We use the frequency map to instantly know how many such numbers exist in nums2. This avoids nested loops and gives us an efficient solution that works even with frequent updates. The solution we implemented is highly efficient in terms of both time and space complexity. In the constructor, we build a frequency map for the second array, nums2, which takes linear time, specifically length of nums2. This frequency map allows us to perform the add and count operations efficiently later on. For the add method, we simply update the value at a given index in nums2 and adjust the frequency map accordingly. Both of these operations, decreasing the old value's frequency, updating the array element, and increasing the new value's frequency, are constant time operations. Hence, each add call runs in one time. For the count method, we iterate through the first array, nums1, and for each element, we compute the required complement that would sum to the given target. We then look up the frequency of that complement in the frequency map, which takes constant time per lookup. As we only loop through nums1 once, the overall time complexity of count is length of nums1 per query. In terms of space complexity, we store the two input arrays, which require length of nums1 plus length of nums2 space. Additionally, the frequency map for nums2 may take up to length of nums2 space in the worst case where all elements are unique. Therefore, the overall space complexity remains linear in the size of the input arrays. This approach is not only optimal but also very scalable for large inputs, making it an excellent technique for solving similar problems that involve dynamic updates and fast queries. Let's now take a step back and talk about the key takeaways from this problem. HashMaps are powerful. Instead of repeatedly scanning arrays, we use a HashMap to store counts and achieve faster lookups. This trick works in many other problems too, such as toSum, subarray sum equals k, and more. Maintain data structures proactively. Notice how we carefully update the frequency map every time we update nums2. This ensures that our data stays consistent and our solution stays efficient. Optimization is often about perspective. The naive solution here would be a brute force approach using two nested loops, but by looking for patterns, specifically pair sums, we can optimize drastically. This is a practical interview question. This problem teaches you how to deal with dynamic data updates and query operations efficiently. A very common interview scenario, especially for companies that focus on data-intensive applications. These insights can help you in competitive coding, interviews, and even real-world systems that need fast querying with frequent updates. And that brings us to the end of this video. We started with a challenging problem, explored an optimized solution, and learned several key strategies that you can apply elsewhere. If you enjoyed this video and learned something new, make sure to smash that like button and subscribe to BugNoJutsu for more in-depth problem solving and coding wisdom. Let me know in the comments if there's another problem you want me to solve in this style. Thanks for watching, and as always, keep learning, keep grinding, and remember, it's not a bug, it's just a hidden feature waiting to be unlocked.